Okay, here goes a spinning class example. It was on page 20 of your booklets, just in case you attempted this and you felt like you needed a bit of help. So imagine there are 3 rows of 6 bikes, right? Because it's 18 bikes, so 3 rows of 6. Okay. There you go. And so what's happening here is that we want a group of 6 friends, right? 6 friends to be in the same row if possible. And they would like to reserve a row. They can't pick a specific spot, except for we know that they would like Allison and Franco on either end. So Allison and Franco on either end. So let's pretend like they got this row at first. Technically, either end means that you could have either Franco or Allison here, and vice versa. So that means that you have 2 options here, 1 there, right? This kind of tells you that you could have them flipped, right? So this is just talking within this 1 row. And then there are 4 spots remaining, so those friends can be rearranged, so that'd be 4 factorial. So technically this is 2 factorial, right? It works out to be that way. And then 4 factorial for the remaining 4 to be rearranged, right? And so what happens now is that the remaining 12 here can be rearranged as well, right? So we have these 4 and these 12 can be rearranged in any way. So you can almost take these 2 and put them in a row and just, right, you can move this over, this individual over here, over here, over here, and it just keeps going, right? So within this row that they would like to stay together, this is what would happen, right? And then the 12 remaining can keep changing. So let's start setting up this is basically our NA, right? Our NA is saying, hey, it's 2 times 4 factorial times 1, okay, times the 12 factorial out here, because they can all still change. But if you think about it, there are 3 rows, right? So these friends could be placed in the 2nd row, and then everything else changed, right? And then in the 3rd row, and everything else changed. So it's almost like this could happen, if you want to put it this way, times 3, right? You could have that 3 times, because them being here is going to be a different permutation as opposed to there. Okay? So that's where the times 3 comes from. And so as you will see in the key, it's best to just leave this one. So I will combine the 2 and the 1 as 2 factorial, 4 factorial, 12 factorial times 3, right? In fact, you could also make an argument if it's 3 times 2 factorial, these 2 could be just combined to just saying 3 factorial, but we're just going to leave that. So that's our NA. NU is absolutely just changing everybody up, not having to stay within your row. You just go every which way. So that's the 18 factorial. So the probability of what they want happening, staying in the same row, would therefore be 2 factorial, 4 factorial, 12 factorial times 3 all over 18 factorial. And here you have to do a little bit of calculating, right, to simplify that, because the calculator gives you a very large number for all of these. So we know how to do that, right? So I'm going to combine the 3, the 2, and the 1. So this and this, because this is 2 times 1. So we can just say 3 times 2 times 1, which is this, times 4 times 3 times 2 times 1, right, for this, times 12. Actually, that I'm going to leave. But down here, I can go 18 factorial, 18 times 17 times 16 times 15 times 14 times 13 times 12 factorial, right? So you can cancel those two out just nicely, and then this is going to be kind of messy, so, but I see that the 3 goes in here once and goes in there 6 times. The 2 goes in here once, it goes in here 3 times. You can, yeah, you can do that. 4 goes in here once, goes in there 4 times. The 3 goes in here once, goes in there 5 times. And you notice that at the top, it basically all cancels out to just 1. Okay, just to 1. So if everything was done right here, we can, I noticed that I missed 1, not that it's, so the 2 goes in here once, goes in there 2 times. So then you have all 1s at the top, and the bottom is now as simplified as possible. And that gives us 1 over 92,820. Okay, that's the probability there. So I hope this helps a little bit. This is it for this video.